We're going to talk about a couple topics today. I'm going to try to run through the first three topics here, and we'll leave a lot of Q&A session at the end so you guys can talk, ask your own questions. So as we go through this, just formulate the questions and we can go over. I have about 40 tweets that have been asked of me between yesterday and today, so I'll try to get through some of those, and then we'll open up the floor for your own questions. But I'd like to just kind of quickly talk about why Google switched to machine learning-based search, how machine learning-based search actually works, and how we actually can use AI today to actually uncover how this machine learning-based search works. And so, you know, if I was a Google search engineer and I was up here trying to answer your questions, this is about as much information as I would be able to give you. They're under NDA, so they're never going to. If you're thinking you're getting real answers from Google's representatives, you're really not. They have a whole team that is basically just to placate the SEO industry to tell you things so that you don't get too upset. But a real answer from a real search engineer, a real question to a real search engineer has yet to be ever answered. I've never seen it. So I've been building search engines for 15 years. I actually built one alongside Google, sort of in parallel, as a way to model Google. And so I guess I'm trying to sort of fill that role to the SEO industry is, you know, whatever project you're working on, whatever part of marketing you're working on, if there's like a missing piece of information that you're looking for that you just wish you could like get that answer from a real Google search engineer, I could probably get you really close. So that's sort of what I'm trying to do today. So just really quickly about me, I co-founded Market Brew in 2006. I'm a Google for Entrepreneurs advisor, and funny story, I've got patents that Google references, we kind of share the same space. This is me unboxing my first computer, 1983, so I was 6 years old, and so I learned how to code really quickly. I got the code bug bit me really early on. Had to program my own games. They didn't come with, you know, like cartridges that you put in there, so you had to actually have a book and you program the games, and the power would go off and then you lose the game and you have to program it again. So that's basically how I started off. Later on in life, I was building large-scale systems for trading systems on the New York Stock Exchange and NASDAQ. And in 2006, I actually met a couple of business owners that sort of learned how to decode Google for their local market. And so I essentially took them national. I sort of replicated it, brought it to scale, and it was sort of my first introduction to SEO, what SEO was. I unleashed the first major link network, I believe. In fact, I believe that the supplemental index was sort of a response to what we did. And I kind of learned the hard way that this was really not a long-term business strategy. So I decided to switch teams. I wanted to show others why this approach, trying to play this sort of hacking Google, was a sort of a pointless short-term approach. And I wanted to really show people that weren't programmers, that weren't technical people, how Google actually worked, how a real modern search engine actually worked. So I got to programming over the last, probably the first 2 or 3 years. I didn't really sleep. I worked about 120 hours a week. I have a number of patents on this idea, this concept of sort of a search engine optimization engine. And essentially what it is a sort of a new type of search engine that isn't used for what you would use Google for. It's really used to introspect on how Google actually works. So we had to build all the components. We started building our own crawler. You know, in 2006, there were no open source libraries or APIs, so this was before Ahrefs, Open Site Explorer. It was even before Yahoo Site Explorer, so we had to learn how to build a lot of components that were not available at the time. We had to model a lot of the families of spam algorithms. I always talk about how we sort of got a cheat code to this because we started early and we were able to isolate every new type of algorithm that Google would add to their search engine. So we had already kind of had a collection of very basic algorithms that we were able to understand. And then as things became more complex, we were able to know exactly, you know, what was the gap in our search engine, what was the gap in the model, and fill that in with the new algorithms that were coming on board. So our first version of search, just like a lot of the search engines, was a rules-based search engine. You had algorithms that you coded up, and they're all rules-based. In 2013, we actually switched to a machine learning-based search engine where we sort of anticipated Google removing a lot of the data from its search engine, or at least the output of what you see out of a search engine, and essentially build what was like a generic search engine that could be manipulated to calibrate itself to behave the same way as any search engine that you pointed at. So effectively, we used a genetic-based algorithm, which we'll talk about in a bit here, to take this rules-based engine and turn it into a machine learning-based engine. So this was sort of the key milestone for Market Brew, was basically building this new type of generic search engine that could clone itself. You could point it at any search engine result page, and essentially it would learn the bias and weight settings on the relationships between all of the algorithms inside of the search engine. So why did Google switch from a rules-based to a machine learning-based search engine? So the algorithm equations used to be really simple. A lot of you who go back way back early 2000s know this. It was fairly simple to classify. If you had two different types of websites, some in the blue, some in the orange. It's a pretty easy way to do this. It's a linear line. You can draw a line between the two and classify these sites as good, these sites as bad. But as the search engines evolved, they became very complex. So now you have to define some sort of equation that puts all the orange in one classification and all the blue in another. And obviously you can do this. You could write a rules-based equation that had this 2 pages worth of an equation to define what the separation between these sites were. But really it becomes a nonlinear classification problem. It's not really a legitimate way to approach the more complexities of classification. So we need to solve these complex equations, and how do you do that? There's no human that can actually come up with these equations that work for all the sites. So neural networks actually became one of the go-to ways of writing these equations. So essentially the neural networks, through machine learning, they would train this data, and we'll talk about a little bit about in detail, but this would give us sort of the equation. And you can see right here, this is a neural net that's learned how to separate the orange and the blue here. So this is kind of a neat little spiral effect right here in this graph. That's an actual equation that it's found to separate the two different types of sites. So with neural nets, you can do a lot of really cool things. So Google's machine learning version it's what we call supervised learning. So in supervised learning, humans are always assigning labels and features to data. So the labels would be more like, is this site spammy, or is this site good quality content? It's essentially the output of what their search engine wants to be. And the features are essentially these rules-based algorithmic outputs, right? So they have these rules-based engine or rules-based algorithms to define how good link structure is and content structure, whatever you want to think about inside of a search engine. Essentially, all these rules-based engines, and then these become features to learn the relationship between the features and what they want the output to look like. So that neural net, in the supervised learning process, what we call training the model, iteratively learns these relationships between the two. How do they label the neural net? Well, there's a thing called the Search Quality Rating Guidelines, which many of you have already heard of. And this is essentially the way that they had humans label their machine learning. So essentially, they would give a list of guidelines of what is a good site or a bad site, a good landing page or a bad landing page, and they would work backwards to learn what the relationships and the bias and weight settings of each of these rules-based algorithms inside of their core engine should behave. So the problem is that SEO platforms really haven't caught up to this. So Google made this switch sometime around 2013 when they really got into identifying pictures. They used things called convolutional neural networks to do this. and they said, hey, this might be applying to help our core engine behave a little bit better. And so they switched over sometime around 2013. And as of 2021, we estimate 95% of SEO platforms still use a rules-based paradigm. So there's a huge gap in the way that people are thinking about SEO today. And so I'm trying to shed some light on why we want to use AI to understand what the AI is actually doing. Peter Norvig made a really great quote, Google research director. This was many years ago, but still stands today, that it's all about running experiments and using statistics and not logic to analyze the results. And that's really a lot of the ways that they introduce new algorithms, or they try to tweak the core algorithms inside of search. They're not really going in and manually changing algorithms. They're relying on these statistical analysis to reweight and bias some of these algorithms. So as SEO professionals, you guys really want to know what is inside the black box. That's the whole purpose of sort of understanding what we're trying to do here. And so the first thing you got to know is that the black box is constantly changing, right? So from one day to the next, depending on how often that they retrain these models, and from one search engine result page to the next, one keyword to the next, all of these are constantly changing. And so the other thing is that the search engineers, me included, can't always give you a straightforward answer. If you ask me, why did this site rank better than another site, I have to go in and statistically look at things and analyze them. And it's not as simple as saying, well, it's this algorithm and it's doing this. And the reason is that you've got this neural network that it many times has millions of neurons that essentially are these bias and weight settings on the model. And it's really not very straightforward to get from the outputs of these algorithms to how the rankings end up. So those two things combined, and that sort of understands why people don't understand what that black box is actually doing. But it turns out you can actually use AI. You can use their own technology, right? Google used AI to improve their search engine, so why can't we actually use that same technology to infer and understand how that actually works? So it turns out you actually can, with sort of taking it up one level higher. So where the labels become the ranking data, right? You can use a ranking API to list out how that keyword is behaving in that search result page. And then the features become sort of the algorithmic outputs of this black box. And so where do we start? The first thing we have to do is create sort of a generic search engine. We got kind of lucky because we started in 2006. Like I said, we were sort of grandfathered in, so we weren't able, if I were to start this now, it would be quite complicated to try to come up with what all the algorithms are inside of a search engine like Google. But it's still doable, but it would be a lot tougher. One of the ways that we determine which algorithms to model is breaking it down into first principles. So you probably have heard this over and over by people like Elon Musk. But essentially what we're doing is we're not reverse engineering the code, right? So we can build search engine models to understand what's in the black box. That doesn't mean that we know exactly how the code operates, but it's sort of an approximation of all the key components that are behaving inside of this black box. And so starting with these sort of first principle algorithms, sort of modern version of PageRank, duplicate content, Panda, Penguin, those types of algorithms. And as we start developing this generic search engine, you can actually use machine learning to determine sort of gaps in the model and fill it, and how certain algorithms may be missing, and explore how to fill those in. Quick warning, you've heard this a million times already, correlation does not imply causation. It's absolutely true. However, correlation is pretty interesting here. It can actually establish relationships, which helps us uncover a lot of things about this black box. So there's, obviously there's a study where it was kind of a funny study where they said TV sales correlated with deaths, right? So the more TV sales increased, the deaths increased, but obviously this just means that the growing population means more TV sales and more deaths, right? So that's very simply explained. However, if you have a relationship defined, in that relationship, that correlation starts to unwind, right? some new factor typically is the reason why that correlation has stopped working. And so the fact that you can establish a relationship and monitor that relationship through time, and as it changes, it kind of signals that, that some new factor has disturbed the correlation that may need investigating. So here's an example of an overly complicated model, right? One of the dangers of trying to emulate something as complex as Google's black box is to make your model too complicated, right? Can you make an equation that separates all of these orange dots and the blue dots representing two different classifications? Absolutely, right? We did it right here. There's a neural network that has come up with an equation that works perfectly to fit this data. But what happens if we add new data to something like this? You get this, right? So it's obviously not fit. The new data does not fit the previously trained model. And the reason why is that there's too many specific or low-level algorithms that we're trying to use as features in this process. So we don't want an overly complex model. We want to keep it simple. The less complex a machine learning model, the more likely that a good empirical result is not just due to the peculiarities of that data set, sample set. This doesn't mean an overly simplified model. You can have a top level of features or algorithms that represent many different complex calculations underneath them. Sometimes many hundreds of sub-algorithms that may calculate that, but it doesn't necessarily mean it. It just means that we're preferring a feature set that explores just the top layer of algorithms to emulate. And also, we don't want to have one algorithm overwhelm the model and take over the model essentially and represent most of the movement in the model. So we use things like weighting ranges and L2 regularization. So this is basically some of the things that you get tripped up on when you go through building these types of models. So what are the benefits of modeling a black box, right? So the first benefit, obviously, is very accurate. It's pretty much the most precise way that you can understand what's happening in any individual search engine result page. So think of it as sort of like a search engine that can calibrate its own settings using machine learning to behave like any search engine that you want. So we have this generic search engine, we can point it at a search engine result page, and we can run through this process, which I kind of skipped over today. It's a little bit complicated to go over all today, but we use a genetic algorithm called particle swarm optimization. And this allows us to take the generic search engine with all the different bias and weight settings and figure out what a global maximum solution is to emulate exactly what we see on the target search engine. So once we have that, we have sort of a calibrated search engine simulator, if you want to think of it that way. There's different ways to name it, but that's what it is. And this gives us really good predictability, and of course the opposite of the risk avoidance features as well. So it allows, once we have these calibrated models, it allows you to make changes, whether that's content changes, link changes, anything in the spectrum of SEO. We can run that through these models, and we can sort of predict what's going to happen when you introduce those changes. Today, what you do is you deploy that to a production environment or to the website, whatever, and Google comes around with its crawlers, crawls all that data, and a couple months later, it all filters out into the ranking algorithms, and either your rankings go up or down. If you didn't isolate those changes, you have hundreds of different changes that you may have just made. There's no real way to actually understand what was a good change and what was a bad change. So with these models, you can actually isolate this. You can make tiny little changes, run those changes through the model, and you can actually understand what that individual change to your site did to your ranking for that landing page, and even other landing pages. And of course, it just gives you a little bit deeper understanding of what's going on inside of the model. We can do things like understanding statistical gaps in the model. We can compare the outperformer. We can actually find the outperformer in the model for every part of search. So we can find the site that does really well with meta titles, site that does really well with content, sites that do really well with the link structure, internal and external. Anything that you can think of, we essentially can identify what those outperformers are. And if you're trying to move up in ranking for that specific keyword, you can basically, instead of emulating the #1 site in that search engine result page, which typically isn't always the first #1 site in every part of the model, instead you can kind of just look at exactly what the outperformers are and go after those for each part of the model. So the concept is really just we want to rethink the way that we do SEO. We don't want to be in a rules-based paradigm. We want to start employing machine learning and AI to actually understand what's actually happening inside this black box. All right, so the end part is I want to kind of go over a Q&A session, but I have about 40 tweets that just got sent in, so I want to go through some of those. So just kind of think of your questions as we go through this, and I'll sort of, once I get through this, I'll kind of go through any questions that you guys have. And at the end of this, if you guys want to see this in actual practical action, come up to me and I can set you up with like just a sort of a freebie, whatever website you want to look at this. And we can build a model for you, and you can see for yourself sort of how this works, if it's interesting or not. So, all right, so let me start with some of this first tweets here. So I'll keep these anonymous, because I don't know if they want me to share them or not. How much duplicate content is acceptable? All right, so that came in as a question. Okay, so, well, I think people get confused when they hear duplicate content isn't bad, right? So, especially from engineers from Google. You get people confused saying, oh, duplicate content is good, it's okay. What they mean here is that sort of a certain amount of duplicate content isn't bad. So the amount that we found in our search engine is typically about 30 to 40% duplicate content is normal. And this accounts for things like headers and footers. You know, when we're writing algorithms to create duplicate content penalties, typically we won't start until they get above 50% correlation. It's sort of a logarithmic penalty that we introduce into the system. And of course, this correlation algorithm is a whole topic on its own, so especially with word embedding and some of the word-to-vec technology, but that should be a good answer for that. How many Google sub-algorithms are there really? Okay, well, there's thousands. So a lot of it is the chicken and the egg thing too. So for instance, like how do you determine the meaning of a page, right? So you may first need to crawl all the links on that page, that link to that page, and then based off of the citation structure around that page, you may sort of determining how powerful that link is. You may also look at the relevancy of that link. So the link citation structure that links to a particular piece of content often can change the meaning of that page, the way that the search engine views that content. And of course, part of the link characteristics that determine which links put more, what we call it link flow share, which links are more powerful than others. One of those link characteristics is relevancy, the anchor text relevancy to the actual target page. Well, to do the relevancy, you have to have already calculated what the meaning of that page is, and to do that, you actually have to use that link signal. So there's you can literally see where you know there's a recursive nature to a lot of these algorithms, where there could be hundreds of different calculations just to get to sort of like that top layer of algorithms that we were talking about before. Next question is, what's an optimization often missed by SEOs that plays a part we should optimize for? I think link flow distribution, that's what we call link flow distribution. It's the link structure, the internal link graph especially. You know, the larger, more successful sites are the biggest culprits. So like, they mask the issue with their backlink structure, right? So a site like Walmart or Home Depot, who has a very big backlink structure, they really don't have to have a very organized link graph, right? They can have a very flat link graph, whereas basically every page, they're telling the search engine every page is relatively the same importance as every other page. Whereas a smaller company or a smaller website that doesn't have as big of a backlink structure has to have a better internal link structure for them to actually compete. So I would say this is probably one of the things that gets overlooked. And of course, the good thing is that this leaves the door open for smaller sites to rank in competitive environments with really large companies. We've often seen like 3 to 4x improvement in equivalent backlink structure. So in other words, you would have had to gone out and got 3 to 4 times the backlinks for a particular landing page, but instead all you did was just change the internal linking structure. So the leverage that you have in this specific instance leads to a really high ROI. So that's why I would say sort of link flow distribution is like one of the biggest things. How does the EAT algorithm work? Okay. So as Google's own engineers have explained, it's actually made up of a bunch of mini algorithms. So let's talk about expertise, right? So how do you define expertise? Clearly, there's an algorithm that defines it. You don't have, there's nobody at Google that's sitting there going, well, that guy's an expert. She's an expert. He's not an expert. So none of that happens, right? It's all algorithmically done. So I can tell you the way that we do it, and I think it's pretty close to the way that Google does it. So I'll bring up Elon Musk again. So Elon, I actually recently, somebody asked him about how do you interview people? And his thing was that the best thing you can do for somebody who claims that they were on a big project, responsible for a big project, was to ask them every detail about that project. Because if they really were responsible for that, they're going to know everything about it, A to Z. They're going to know everything about it. And if somebody really wasn't part of the project or they were just on one piece of it, they're not going to know that full spectrum. And so EAT is sort of the same thing, that the expertise algorithms at least are the same thing, where given a set of words on a page, how complete is that word graph? In other words, if I was an expert and I showed you all the content that I would write about a topic, and that represented the full word graph, I'll call it a word graph of content. Is the content I'm looking at, is that the full graph or is it missing part of that graph? And so we can measure how much is missing. There's actually technologies like Word2Vect where we use CBOW, it stands for Continuous Bag of Words. And essentially what it does is you give it a set of keywords, and it can tell you sort of what other words are missing. And so that's sort of how EAT works. We actually use algorithms to determine sort of how complete that word graph is for any piece of content. How does search engine incorporate new algorithms like Core Web Vitals? Okay, so like any new algorithm, it becomes a new feature in this machine learning model, right? So it is a rules-based algorithm that we introduce. Like for instance, Market Brew, we're already collecting billions of different data points on every single website. The way we do this is we have a JavaScript rendering engine that every time we crawl a page, we're able to inject the Core Web Vitals scripts onto that page, even if it's not on there. And we can run that in the JavaScript rendering engine and determine what the FID, CLS, all this other stuff that you're familiar with, the Core Web Vitals. So once we have that data, then we can run experiments, right? To go back to Peter Norvig's quote, we're running experiments to see how correlated or how much of an effect these settings have. And so there may be cases where in certain SERPs you may have no change, right? So Core Web Vitals has no effect on it, and that could be just because maybe all the sites suck, right? They all just have really bad load times, and they're just rest of these sites, I'm looking at you. But in other competitive environments, it could be that it could be a determining factor, right? When you get into competitive environments, you really have to start looking at statistical gap analysis because they're so small that the differences between these sites are so small that that's where the advantage actually lies. And so it could end up being that whether Google wanted it to or not, it could end up being a big factor. So it's really just collecting the metrics, getting the instrumentation first at scale, and then applying that to understand if there's actually any correlation or any discerning difference between the sites. And I would say, if you're going to follow up with a question like, what should I do with EAT? If you were in a situation where you saw in that model that a competitor was sort of the only difference in the two sites was that the competitor had better Core Web Vitals scores, it would just be like anything else, which is essentially just copy what they're doing. And when I talk about copy, I'm talking about UI frameworks, UI implementation, anything that can affect Core Web Vitals. Just look at how they're implementing their site and try to at least null out that gap. How does a search engine handle similar words in a query? Okay, so technologies like Word2Vect and transformer-based machine learning like GPT-3 that you guys all hear about now give us the ability to embed words in queries, and actually it gives us the ability to embed words in every part of the search engine. So different algorithms like content algorithms, we can use the same technology. So that whether that's determining the meaning of a particular page or substituting the user's query for with related keywords. we're able to use those keywords to as sort of a vectorized based keyword approach. So in the modern search engine, we don't really think of keywords as individual words or phrases. We view them as vectors. So we say, here's a keyword and there's a vector associated with it. And that gives us the ability to do things like cosine similarities between individual words and stuff like that. And you type in something into Google, and really what's happening underneath the hood in the query parser is it's that word with 1,000 other words with different weighting factors that are related to that word. So that's essentially what's happening underneath the hood there. Does Google really see JavaScript links? Most of them. So it doesn't even require a user clicking on these JavaScript links to understand them. So in Market Brew, what we do is so obviously if we loaded up a page and enabled our JavaScript renderer and started clicking on every individual link to see where that link actually goes or what it does to the DOM, it's not a very scalable solution. And so what we do is we have tricks where we'll pick up, if there's 200 JavaScript links, they all look the same with some obfuscated code in the tag. We'll click on one of the links and see what it does. And then we'll look at the other 199 links, and if they're exactly the same code base, we can infer what the other 199 links are going to do. And so we don't have to go through and click all of those. So it speeds up the process and it works better at scale. Will GPT-3 kill off content writing? So GPT-3 is sort of like the search engineer's nightmare right now. So it probably is what keeps Google search engineers up at night. It's going to be a challenge for Google in the way that it evaluates content moving forward. After all of these technologies, it's basically what GPT-3 is doing is it's sort of completing that word graph that I talked about before, right? So it gets you to the expertise. It raises the bar on what expertise content really is, right? So in the future, that will be sort of the minimum content. It will be sort of like what's already been written out there, right? If you don't even have that, then you're not even in the game anymore. So the GPT-3 type algorithms, which complete the sentences or complete the word graphs and give you the rest of the content that an expert would actually provide, will sort of be the minimum content, and you'll need to provide more unique content on top of that, something that actually hasn't been written about. So it'll be sort of the combination of both. You'll have to have the full word graph, and you'll have to have additional stuff that isn't out there. That's just my guess. We haven't really solved that, and I don't think Google's solved it either. They're probably really worried about it. We know that Google classifies certain things such as local, your money or your life, adult. Is it the content, the query, or both that gets classified? Both, right? So they're very different in nature, right? So the query classification is more of a blacklist, right? So they can come up with just a rules-based algorithm to blacklist certain queries. But on the content side, it's different, right? So the content side, think of it as sort of like a raised threshold for these EAT algorithms, right? So in certain instances, maybe medical sites, the authority level or the expertise level needs to be higher. And so all they're doing is basically they're raising that bias and weight setting on those types of sites. So they have a list of certain industries or sites that they want to have this raised threshold, and that's basically all, it's just a flick of a switch. They're just pushing that algorithm a little bit higher up in weighting for those types of sites. At least that's how we do it. Google has hundreds of ranking factors. Are they all manually discovered, or are some of them found via algos? Most of the features of search engines are manually created. So, like, we go back to how the modern machine learning based search works is you've got algorithms that are rules based, and these are created by engineers to try to identify or classify certain things, and they use the neural net or the machine learning process to change the bias and weight settings of those algorithms. So yeah, they're mostly manually created. Although it would be really cool if it was algorithmically created. I think that gets into like sort of unsupervised learning, which is kind of cool. What's the biggest waste of time optimization? So I would say this depends on the search engine result page. So some optimizations are useless in certain contexts, but they could be critical in others. So I'm not trying to evade the question, but it's really, there's no fixed bias weight settings anymore in the search engine, so these can change whenever they rerun their model. So yeah, there's no clear answer. What might be silly to optimize in one specific area might be critical in another. Does Google still utilize the number of occurrences of a word, phrase, string, which appears for topicality relevance or spam detection, etc.? So I would suspect so, although it's not just counting the same words now. We're counting related words, and we talked about that vectorized approach to viewing keywords. Everything is sort of used in that frame of reference. So I think the penalties have changed. I think there's less weight than on this now than now that they can calculate other things like expertise, right? So they're not relying on sort of just strictly looking at words on the page. Each year, Google seems better at handling synonyms and variants. Does it utilize other approaches such as lemmatization or stemming, or things such as collocates or contextual framing, or is it now based on position in things like word to vect, phrase to vect? Okay, this is a very long question. So the query parser indexer still uses stemming to get to sort of the base root word, but then it sort of quickly diverges into using things like word to vect where we get the similar words. So it's sort of a combination of the two. Google says schema usage doesn't improve rankings, but people show improvements with implementation. Is this semantic evasion by Google or coincidence or something else? So schema helps Google format their search engine result pages easier. They typically will avoid using easily manipulated things for ranking algorithms. So if you can manipulate that, schema is a very highly manipulative thing. It typically will stay away from core algorithms as signals. But it will help you overall because obviously schema is helping you format your results, so you're going to appear more prominently in the search results. You're going to have better user experience when they're trying to find your content. So it's sort of a different meaning, but it's not, I wouldn't say that they really kind of use those in the core signals. Google remembers things. As some cases, a new site will suffer the consequences of an older site's actions due to a domain name. Is there an easy way to discern this for a business owner, and is there any way to correct it for those that couldn't spot the issue? I think the days of sandboxes are long gone. You know, the old day of getting sandboxed. You know, the crawling and indexing systems are very smart about throttling and resource utilization. I think caffeine was like a big change that they rolled out in 2000, I don't know, someone say 15, I don't know, but yeah, the crawling and indexing systems are very, very smart, so they can throttle up and down very easily and efficiently. So I wouldn't worry about getting stuck in some sort of supplemental or sandbox situation if you go and acquire a company's site or something and you're worried about what happened to them before. You know, Google crawlers will crawl the new content. While it may be initially slow, it'll throttle back up once it determines the site's different. What's your favorite part of algorithms and why? This is a good question. So I love how, I guess my favorite thing is that I love how the PageRank calculation has evolved over the years from a simple pass-through link flow value or link value to what it is now. Which is essentially a huge list of link algorithms that sometimes, you know, we talked about this, have a recursive nature to them. I think the fact that the general, what the PageRank calculation is based off of eigenvector matrices, I think that concept of the eigenvector matrix is that it hasn't changed over all the past 20 years is remarkable to me. There are very many core concepts that just kind of stay the same over time. Of course, there's better link algorithms today due to technologies that have developed over the years, but the brilliance of the PageRank idea still still stands in some form today, so I think that's quite remarkable. I'm also very excited about vectorized words. I know I've already talked about this in cosine similarities and stuff like that, and how they've eliminated much of the sort of the hard-coded NLP graph. NLP and entity labeling, it's a fascinating thing, and I think the word-to-vec stuff and a lot of the similarity words system that we're developing in Market Brew actually is very exciting because it doesn't have, you don't have to actually understand what the meaning is between the individual words. It's really breaks it down to just sort of a mathematical similarity system, which is kind of very cool. I don't think that replaces the sort of an NLP approach. I think it just supplements it. It gives it a little bit more diversity. What's your least favorite approach that you know of in the system and why? If there was one part of the entire system you could ditch and burn, what would it be and what would you replace it with? So I think adding like very manipulative tags like nofollow was sort of a very short-sighted approach by Google. Anything that could be easily and directly manipulated is sort of like the enemy of the state, but for a search engine here. So Google already burned that house down though, so hopefully if they've learned that lesson. Author rank was another one. Thinking that the industry wouldn't manipulate that, I thought it was pretty naive. What is the most common innocent spam that sites tend to accidentally trip up on? Not real spam, just a stupid mistake that often leads to false positives. Things like advertorial or paid link penalties. We see a lot of sites that get tripped up into those kind of penalties. They didn't really intend to do that, but just as, you got a content writer and they typically don't think about the link structure around their content, and that's where they can kind of get in trouble. So I think that would probably be a good example of that. Last question on Twitter. Canonical links are suggestions. Google gets to decide whether to heed them. This suggests there are conditions to be met, such as a degree of similarity. Is there a consolidation binary or graduated? Is there a set degree of similarity required? Is the value 100%? Well, I obviously can't tell you exactly what Google's settings are, but inside of our search engine, yes, there is a set degree of similarity required to have a canonical tag actually be legitimate. And so the thinking is that it prevents a lot of the artificial manipulation that you might see if somebody tried to take advantage of this, like a nofollow tag or any other thing that they would try to sculpt link flow or page rank. I think we set ours at 95%. So it's something, I would presume it's somewhere between 90 and 100% that the two pieces of content have to be similar enough for the canonical tag to actually register. Okay, that's everything from Twitter, so I'll take a question. If you guys have any questions, go ahead. Maybe I already answered them all. I don't know. Do we have a mic?
She's right there. I thought you were ready.
Thanks, that's actually really interesting. How much does, when a site moves to a different domain, how much does Google rerun the model? Does it start fresh, even if there's 301 redirects? Because I sort of get the sense that there's a lot of inherent goodness in an old domain, and when you get to a new one, everything gets recalculated. Is my sense correct, or am I thinking about this all wrong?
Well, I mean, the first thing to think about is there's no real delineation between domains, right? Like, it's just, you think of a domain as like a grouping of content, right? So to Google, and again, I preface this with I have not reverse engineered Google's code,
Right.
So I really don't know exactly what they're doing. Well, I can tell you what we do is whenever there's new content, we typically don't do a reset. We'll typically rely on all of the typical settings like 301 redirects and you can seek different ways to basically tell the search engine that it's in a different location. But we typically don't do a hard reset. That being said, when you do have these sort of redirect of signals, they take longer just because there's an intermediate step. And oftentimes, like if we were running a full-scale live search engine like Google, you wouldn't want the change to just happen immediately because it couldn't just be a temporary thing. So you don't want to just commit the whole shebang and all of a sudden have to do it all over again. So I could see like some sort of temporal thing where it just sort of takes a little bit before it kind of locks in. And then also just the way that the PageRank, if you study like the PageRank calculation, there's a modifier on each iteration as it passes link flow or PageRank through from page to page to page. And so this can also have some sort of like that effect, possibly just temporarily though, as it tries to like wash out the old content out of the graph of content that it has in its index and put in the new content. So, yep. Next.
So actually, has to be the last question. I want to give you guys a minute or two to use the restroom or anything before our closing keynote. But thank you, Scott, very, very much.
Yeah.
And Scott, you're coming to the Olive Branch, right?
I am.
So there you
just
go.
come up to me and ask.
Yeah, you get your one-on-one answer.